Now we're going to start learning about this thing called a recursive rule. So this is another formula, just like the formula we learned from the last lesson. So here's the formula for this recursive rule. And this particular formula, you can use it to find any term in the sequence, which we'll represent as a sub n, so that's any term in the sequence, so long as you have the term that comes before it, which is going to be represented as a sub n minus 1. Okay, so you're only allowed to use this formula if you have the term that comes before the one you're trying to find. So for example, say you wanted to find the 100th term in the sequence, which is a sub 100. And you want to do so by using the recursive rule. Well, you could only do that if you knew the term that comes before it, which is a sub 99. So if you knew what that was, then you could find a sub 100. All right, so here's an example problem. Like, what if you only had the first 3 terms? You had a sub 1, a sub 2, and a sub 3. How on earth could you find a sub 100? Okay, well, you could find a sub 4 since you have the term that comes before a sub 4, which is a sub 3. This comes before the 4th term. So I could use the 3rd term, find the 4th term. All right, well, then if I found this, I can use it to find the 5th term. And then if I have the 5th term, I can use it to find the 6th term. The 6th to find the 7th, 7th to find the 8th, 8th to find the 9th, step by step by step, until I finally arrive at a sub 100, which would take forever. Absolutely forever to go step by step by step by step until I finally get there. Okay. So the word recursion, which is where I get the recursive rule, it's just something that's acquired from prior or previous terms. So I could only find a sub 100 if I have every single term that comes before this term. That's the only way I could find it using the recursive rule. All right, so that's what a recursive rule is. So what's the difference between this and an explicit formula? Well, an explicit formula allows you to get to a sub n, and let's call that the 100th term. It allows you to get to the 100th term immediately, okay? While a recursive rule, it forces you to get all the terms that precede or that come before a sub 100. Okay, I have to get all the ones that come before it. So, yeah, recursive rules kind of suck. I mean, just from what we've learned about them so far, explicit formulas seem a whole lot better because it just gets you what you want immediately, like right away. Where recursive rules take a lot more work. So why are we learning them? They are really beneficial to just understand like the format of how they work, especially if you get into any kind of field like coding or something, because you use a lot of recursive rules in coding. Okay, so if you plan on going into a field like that, it makes sense to like understand just how a recursive rule, like the format that we use for it and how it works. But the big goal of this lesson is just to teach you, hey, when you can, use explicit formulas instead, because they're just a lot better. They just get you what you want immediately instead of recursive rules. So let's say we have a recursive formula right here, okay? In a format for a recursive rule, you'll have a sub n equals a sub n minus 1 plus d, and if you remember what d is, that is your common difference, or the pattern in your sequence. And it's also going to have the first term. It is always going to include that for a recursive rule. So you can't write a recursive rule without knowing what the first term is, okay? So here is our recursive formula. There's the first term that they gave us, and then the actual formula. So I want to use this to find the next 4 terms in the sequence. Okay, so right now I already have the first term. What then is the next four. So the second term, the third term, the fourth term, and fifth term. Okay. So I can find the second term by just taking 2 and I'm plugging that in to every spot that I see an n. Okay, so a sub 2 minus 1, and then all of that is being subtracted. You subtract 4 from it. All right, so we can simplify this a little bit. Like the 2 minus 1, we know that just simplifies to 1. So we can change this to a sub 1 minus 4. All right, well, we know what a sub 1 is. The first term in the sequence is negative 9. So I am going to take this a sub 1 and I'm going to replace it. I'll substitute in that negative 9. Okay, so then that second term in the sequence is just going to be negative 9 minus 4, which is negative 13. There we go. Okay, so that is the second term in the sequence. And now we could take the same formula, apply the steps again to get the third term. So what is the third term in the sequence? So again, I'm just taking that 3, plugging it into everywhere I see an n, which is here and here. So a sub 3 minus 1 is 4. Well, that just turns into a sub 2 minus 4. And guess what? We know what the second term in the sequence is. A sub 2, the second term in the sequence is negative 13. So I'm going to plug in negative 13 for a sub 2. All right, so then I get the third term in the sequence, which is negative 17. Let me do this. Okay. So maybe you can kind of see what's going on here in the midst of all of this kind of craziness that we've been working through. Okay, the first term of the sequence is negative 9, second one is negative 13, and then the next one is negative 17. So by that logic, what is the fourth term in the sequence without using the formula? Okay, well, it looks like I'm just subtracting 4. So just take negative 9, subtract 4, subtract 4. So if I subtract 4 again, I should get negative 21 without even using the formula. So this is a little trick just to bypass all of the work from the formula. We just know that the pattern is we just take the next number and just subtract 4 from it. That's it. So then the fifth term, if we just have this negative 21, we just subtract another 4, we get negative 25. Okay, so that's essentially what I want to teach you is you can use the formula and go through all the steps of it, but you can kind of outsmart the formula and just look at what the pattern is. Like the pattern is I'm just subtracting 4 and just skip all of the work of doing that formula over and over again. Okay, so for example, this problem, the next one. So given the first term in the sequence in the recursive rule, find the fifth term in the sequence. What is the fifth term? So I want to be careful here because this is not an explicit formula. I wish I could just plug in 5, you know, in for these n's and it would just give me the answer that I wanted. But recursive formulas don't work like that, so I have to go step by step. Okay, so I would have to start out by finding B2. Okay, what's the second term in the sequence? So I could go through using the formula, but from what we just learned, I just look at that number that's at the end, and this is the pattern, this is D. Okay, so I'm just going to add 10 to get the next number in the sequence. So negative 3 plus 10, well, it gives me positive 7. Okay. And if I wanted to find the third term, well, I'm just adding 10 again. So I get 17. To get the fourth term, I add 10 again, 27. So the fifth term in the sequence, if I just keep on adding 10, I finally get 37. Okay? So this is just kind of skipping all of the work of doing that formula. I'm just adding 10 over and over again. So that is the fifth term in the sequence. All right. So some other problems you'll see. So we're going to take these two recursive rules that you were given, so this recursive rule and this recursive rule from the last two problems, and we're going to rewrite them as explicit formulas. Okay. So if you recall what it took to make an explicit formula, okay, so to make an explicit formula, we needed two things, okay? We had to know what a sub 1 is, and we also have to know what d is. Those are the only two things that we have to know, and then we can make an explicit formula. So a sub 1, if we're trying to rewrite this first one, a sub 1, that was just -9. Where d, the pattern, d is that number that's at the end, so d is -4. All right, so now that I know those two things, you can maybe look at like the notes for the last lesson, but I'm just plugging those into our explicit formula, which looks like this. So a sub n equals a sub 1 plus d multiplied by n minus 1. Okay, so I'm just plugging those two values in for d and a sub 1. So I get -9 minus 4 n minus 1, and then remember we have to simplify this, right? So we distribute, we get -4n times, well, that'll be +4, and then +4 plus -9 gives me -5. Okay, so this simplifies to -4n minus 5. So we took this horrible recursive rule, which we don't like at all, and we changed it into a beautiful explicit formula, which is a lot more useful to us, because now, if I wanted to find the 100th term in the sequence, I don't have to go step by step like this. I can just plug in 100 right away, and it'll give me the answer. All right, let's try this one more time for the second problem. So again, I just need to know what a sub 1 are, or what a sub 1 is, and what d is. So I have -3, and then my pattern is I'm just adding by 10 each time. All right, so if I'm plugging that into an explicit formula, okay, I have -3 plus 10 multiplied by n minus 1, and then I just distribute this 10, right? Just distribute it here and here, so I get 10n, and that is -10, so -10 with -3 makes -13. And there we go, so that's our explicit formula. So this problem just showing you how to take recursive rules, which suck, and then turn them into wonderful explicit formulas, which are 10 times more useful. Next problem says, okay, so what information do you need from a sequence in order to write a recursive rule or an explicit formula? So if I have a recursive rule, or if I want to write an explicit formula, what do I need? What do I need to know? Okay, so the big thing you need to know for both of these is you have to know what a sub 1 is, and you have to know what d is. So no matter which one of these you're writing, those are the only two pieces of information that you have to have, and then you can write either one of those. Okay, and then the last thing we'll look at is a word problem. So we got Franklin here. He just got a job as a penguinologist, and he decides to deposit his money that he's getting from his wonderful job into a savings account. So he's going to deposit the same amount of money into his savings every week. So he's doing this weekly. The second week, so a sub 2, he has $460 in his account. And then the third week, he has $520 in his account. So a sub 2 on the second week, that's how much he has, and then the third week, this is how much he has. So if we want to take this information and then we want to write a recursive rule from it and an explicit formula. Okay, so remember the two things we need from either of these. We have to know what a sub 1 is, and we have to know what d is. Well, right now we don't have the first term in the sequence, we just have the second term and the third term. So let's examine these two terms a little bit closer. So maybe if we find the pattern, then we can figure out what the first term was. Okay, how much did he deposit, or how much money does he have in his account on the first week? So remember, if I'm trying to find D, I'm going to take the third term and I'll subtract the second term from it. And that's going to give me my pattern, or my common difference. So 520 minus 460, I get 60. Okay? So it looks like every week he's adding $60 into his account. Okay, so if we go backwards, he should have had $400 there the first week, and then he added $60, and then he added another $60. Okay, so he just keeps on putting in $60 over and over again. So the pattern is he's adding $60, and then that first term is $400 in his bank account. So let's see. Let's say I wanted to write a recursive rule first. So I have a sub n equals a sub n minus 1 plus d. And remember, I always have to say what that first term is. Okay. So the only two things I got to plug in is that a sub 1 is 400, and then d is plus 60. Okay. So now that I have those two things, that's all I need to plug in to make a recursive rule. That is it. Okay. Where the explicit formula, I have to plug in, remember, the first term, so 400 plus 60, and all of that is multiplied by n minus 1. So that'll simplify to 60n, and then if I just do 400 minus 60, I get 340, once that's completely simplified. All right, so there's my recursive rule, there's my explicit formula that models the situation. So how much is this guy going to have in his bank account after one entire year goes by? Okay. So I get to decide which of these formulas is better to use. Remember, we've been talking about recursive rules are no good. They take way too long to figure out the answer. So I'm preferably going to choose the explicit formula. This is way better. So let's see. He's doing this every week. He's depositing money into his savings account every week. And he's putting $60 in after every week that goes by. So in 1 year, well, let's see, how many weeks are in a year? So you might need to look that up, but if you know that off the top of your head, it's roughly 52. So there's 52 weeks in a year. So I want to see what's happening on the 52nd week. Okay, or what's the 52nd term in this sequence? So I can take my formula here, plug in 52 in for both of those ends. And this is going to tell me how much money he should have after a whole year has gone by. So 60 times 52 plus 340, that gives me $3,460. So his money grew quite a little bit over the time that he was depositing that over a year. Okay.